Recording progress.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. I welcome you all in our today's online session. Hope you all are fine and having good health. We start today's session with the words of Holy Quran. So hopefully my voice is clear at your end and my screen share as well at your end. So in last we discussed about the concept of curl and about the concept of curl. There are three types of aspect of curl calculation, that is rectangular coordinate system, spherical coordinate system, and cylindrical coordinate system. And in last class we discussed the rectangular coordinate system based curl and the cylindrical coordinate base system curl. And today we going to start the topic of curl, that is spherical coordinate system base. So first we need uh, the vector field, and last we already discussed that curl is the operator which can convert the vector field into rotational field. So here we have the vector field, that is capital A equal to r square sine theta, position vector r cos theta, position vector theta, r sine phi, position phi. So if we implement the curl on a vector field, that curl of A at a particular point r theta phi equal to 2 comma pi by 3 comma pi by 4. So we need to calculate the curl at this point, curl of vector field at this point. So first we need to implement the curl by the formula. So in first step, the formula of curl in spherical coordinate is 1 upon r theta multiply by the curl of this operator, and all these value of the position are r theta and r sine theta phi, dawa by dawa r, dawa by dawa theta, and dawa by dawa phi in second row, and in third row ar r a theta, r sine theta, and a phi. So over here we need to expand this determinant, and expanding the determinant we further implement by the formula. So formation of formula of spherical coordinate by this expanding the determinant expression, and we need ar, a theta, and a phi, the position vectors, and extracting the value of these coefficients by r sine theta is ar, r cos theta is a theta, and r sine theta is a phi. So these three expressions are right over here is the spherical coordinate coefficients in which we use it in our spherical coordinate base curl formula. So in second step, we need to compute the r a theta and r sin theta a phi. So over here, we need to simplify r into r cos theta and further aspects. So each and every individual we need to find by the formula by expanding the determinant 1 upon r sin theta, dawa by dawa theta, the first expression that is r square sin square theta, that is the simplification of a theta r theta, minus dawa by dawa phi r square cos theta. So after the simplification, we got the AR. So AR expression is 1 upon r sin theta into 1 upon r sin theta into 2r square sin theta cos theta. After the simplification, that sin and r is cancelled by these two terms and we got 2r cos theta, the remaining one. And we know that if we need first calculate, there are the three concepts in curl, that is AR, A theta and A phi. So the first expression we calculate over here having the formula of answer 2r cos theta. So over here we calculate that the value of r component. R is the AR. And the second one we need to calculate over here is theta component. And the theta, as per the curl formula, 1 upon r multiply by the whole 1 upon r sin theta, 1 upon sin theta. Dawa by dawa phi AR minus dawa by dawa r into A phi. So this is the second expression at which we got the A theta, and another way we can say it's a theta component. The second term. First term is what? First term is R, or we can say A R, having the answer 2R cos theta. And in second term we need to calculate that term is we called theta component, as well as we said we called it A theta. So 1 upon sin theta dawa by dawa phi AR minus dawa by dawa R A phi. So after subtracting these two things, we got the value of answer over here. So coming towards AR by dawa theta. So there is no term of phi that by taking the derivative, we multiply by the r sin theta, that is the expression is 0. So the whole value is 0 over here. Minus dawa by dawa r. So the expression is a theta is r square sin theta. And taking dawa by dawa r, we take the derivative with respect to the r, that is 2r. And sin theta is just remain right over here. The whole 1 upon r is multiplied over here. R in numerator and denominator cancel with each other, and we got the value minus 2 sine theta. This is the second component that we find over here. The first r component having the answer 2r cos theta, and the second component, the second expression in curl operator having the answer 2 minus 2 sine theta. Now coming towards the third component, that is phi component. We know that in spherical coordinate, we have three values, that is r, theta and phi. R, theta, phi components we need to find over here, and we got the value. We extracting the value and placed in the formula. Okay, the last third expression in terms of dawa of derivative in partial derivative, that is as per the formula 1 upon r of the expression whole bracket dawa dawa r into A theta minus dawa by dawa theta with respective to the AR. So both the value of A theta and AR we getting from the vector field and place over here, that is the R into R, that cos theta, R square cos theta, and the AR expression is R square sin theta. So this term of R square into cos theta is derivative with respect to R, and we got the value 2R cos theta. So R is not derivative toward the concept to by the cos theta. It's a multiplying factor. We write directly over here. Okay. R squared sin theta, we derivative by the theta would be sin theta taking the derivative, that is minus cos theta. So sin of the derivative is plus cos. So multiply sin is multiplied over here by the R square cos theta. Okay. After the whole R 1 upon R is multiplied with each other, and we got the value 2 cos theta. R also cancel with each other, that is cos theta, and taking the derivative common after taking the derivative, and we got a cos theta common from these two terms. So at the end, 2 minus R, we got the answer of the phi component, that is also called the A phi. So at this end, we got the value, the third component, the third answer after AR, A theta, and A phi. So all these answers we got, and this is the AR, that is 2R cos theta. A theta is minus 2 sin theta, and the phi component is cos theta 2 minus R. So these three terms is writing over here, and now further, the curl is the operator which can convert the vector field into rotational field. So the rotational field three components of AR, A theta, and A phi we got over here. And in sixth step of this expression of question is we place the point 2, comma, pi by 3, comma, pi by 4, and getting the answer by placing all these values. So simplification is cos pi by 3 is 1 upon 2, and sin pi by 3 is square root of 3 by 2. So coming over here, that R component would be transformed and represented in this form, that is the 2R cos theta, that is 2 multiplied by R is 2, and cos theta is 1 upon 2. So what we are doing, we find the curl of spherical coordinate expression and place the point over here and calculate each and every individual values of AR, R component, theta component, and phi component at a particular point. And that particular point is 2, comma, pi by 3, comma, pi by 4. So over here, the third component, that is theta component, at a particular point is minus 2 into sine theta. Sine, the theta is the pi by 3, I think pi by 3. Sine pi by 3 is square root of 3 by 2. Multiply by minus 2, and we got the value minus square root of 3. And in last, the phi component, that is cos theta into 2 minus r, we place the value r and cos pi by 3, pi by 4, sorry. So cos pi by 4 is 1 upon 2. So the value after simplification, we got 2 minus 2 is 0. The whole 0 would be multiplied by minus 1 upon 0 becomes 0. And up till now, we place all these values, and the curl operator at the particular point, we got the answer 2r minus square root of 3 a theta and plus 0 phi. This is the expression of curl of A of a vector field. The rotational field would be represented in this form at a particular point. So up till now, if any one of you, if any kind of question, query or difficulty, you may ask, I will answer the kind of question, and resolve your queries if you have in your minds. So up till now, we have discussed the concept of curl operator, and in last class, we already discussed the concept of curl of rectangular, cylindrical, and Cartesian coordinate. So this this is the formula sheet, and already I have shared in your group the curl in Cartesian, cylindrical, and spherical coordinates. So in last class, the Cartesian, which is also called the rectangular coordinate system, we find the curl of rectangular coordinate by the formula. We already find these values. And after that, cylindrical curl by the formula, we already implement these values. For the sake of simplicity, we need for this expression, that is in first one in rectangular coordinate, we need ax, ay, az to solve the curl of a in Cartesian coordinate system. And for cylindrical coordinate of curl, we need uh, raw a raw a phi az. In another way, in some of the expression, raw instead of r, we can say that ar, a phi, and az. All these expression in 6 times we need to place over here, simplify, and we got in last value that in last we got uh, in representation of ar, a phi, and az. And in last, today we discussed the concept of curl in a spherical coordinate system, and that is the curl of A of a spherical coordinate system, that AR, A theta, and A phi, all these expression in today's class of question I've already discussed. So this formula sheet already discussed with you guys, and hopefully there is no query up till now. If anyone of you, if any kind of question, query, or difficulty you may ask, I will answer the kind of question and resolve your queries if you have in your mind. Hopefully there is no kind of question query, hopefully, and have no kind of question. So in last, I have discussed the concept in the series of concept of divergence in Cartesian, cylindrical, and spherical coordinate system. After in the divergence, we have discussed the concept of the gradient operation of rectangular, cylindrical, and spherical. And after that, we have discussed uh, the curl operator, that is Cartesian, cylindrical, and today the curl of spherical coordinate system. Hopefully there is no kind of question, query, and difficulty at your end, and all things have been clear. There is no kind of question and query at your end.